So now I'm going to try something a little different. Instead of having this 4 and 6, I'm going to have this be 4 and 2 long. So we are dividing this side, and we are going to divide this side to 1 and 3. So now, if we want to go work out this area, we can work out each of these little segments and then add them all together. So we have our area 1 is then 1 times 4. Our area 2 is 2 times 1. Our area 3 is 3 times 4. And our area 4 is 2 times 3. Okay. And then we add all of these together to get the same answer as we would have gotten over here. So another way that you can do essentially this is the same way that you guys did with expanding brackets. So we have 1 plus 3. So this gives us, we're using our FOIL method first. So we've got 4 times 1, so that gives us 4. And then we've got outside, so that is 4 times 3, so that gives us 12. Insides, 2 times 1 gives us 2. And then last, so 2 times 3 gives us 6. And that's going to give us the same answer again as this. So this is 24. Adding all of these together gives us 24. This gives us 24 as well. So they work the same way. So now I'm going to draw another rectangle, except this time we're going to be using x's. So here we have x plus 4, and here we have x plus 2. So now if we go work it out, you work out your area, you will have x plus 4 times x plus 2, which gives us x squared plus 4x plus 2x plus 8, which gives us all together x squared plus 6x plus 8. Okay, so this over here is our area, and these over here are our sides. So when we went from our sides to our area, we used FOIL, which I believe you guys did last time. So this time, we're going to be doing quadratic factorization, which means that we are going to be going from our area back to our sides. So we're going to take this expression that we have here, we're going to do some things to it so that we can get these two brackets out again. So that is exactly what quadratic factorization is and why we do it. Okay. So there's a bunch of methods that we can use when we do quadratic factorization. Our first method is called the common factor method. So I have a few examples here. So our first example is 3x squared plus 6. So here we've got a 3, and this is 2 times 3. So we can take a 3 out from both sides. So we're going to end up with 3 times with x squared plus 2. And this is the brackets that we end up having. If we have x squared minus 8s, s squared minus 8s, then we can take an s out from each of these. So we end up with s times with s minus 8. And that's our two brackets. Here's our one bracket, there's our other bracket. So another example, 16y squared plus 8y. So here we have two things we can take out. We can take an 8 out from both sides, and we can also take a y out from both of these. So we can do that. So 8y, so this gives us 2y plus 1. If you are unsure, do them in separate steps. So if we have 16y squared plus 8y, Then we can take out an 8 first, which leaves us with 2y squared plus y. And then we can take out a y. So then we have 8y over here, which leaves us with 2y plus 1. We get the same answer. If you are unsure, you are nervous, you are very, very stressed for time in your exams, do this method. It's fine. They are not going to penalize you for taking one extra step. Okay. Our second method is the difference of squares method. So difference of squares looks like this. We have some kind of something over here, which is squared, and then we have a minus, and then we have something over here, which is squared. Okay, if you look for that pattern, then you can use this method to try and solve these. So we have n squared minus 49. So this n squared, that's a square, and 49 is 7 squared. So we have n squared minus 7 squared. So if we go and take out our brackets, we end up with n plus 7 and n minus 7. So let's test whether this is the actual answer. We can go back by using FOIL. So first will give us n squared. Outsides will give us minus 7n. Insides will give us plus 7n. And then lasts will give us minus 49. So these two cancel out. We end up with n squared minus 49. Okay, so that is difference of squares. So I'm going to do another one over here. X to the 4 minus 16. So here, this is x squared, and here we have 4 squared. So we've got x squared plus 4, and we have x squared minus 4. This over here is again a difference of squares. So we can do this with our second bracket again, which is going to give us, x plus 2, x minus 2. Okay. When you get to your answers, you can always check them by using FOIL. So if you are in any way unsure of your answer, or you think you may have made a mistake somewhere, or you are stressed, do FOIL, make sure your answer is correct. Okay. So I'm going to do 2 more examples of this one. So another example, 16g squared minus 81. So here you can see that we've got numbers along with our g. So let's just go turn this into something slightly more understandable. This is 4g squared. 4 squared gives us 16, g squared gives us g squared. Great. And then our 81 is 9 squared. Okay. So if we go and separate out our brackets, we have 4g plus 9, and we have 4g minus 9. Okay. Our last example, 8y squared minus 32. So here, this isn't a difference of squares, but this sort of looks like it could be a difference of squares. So we can go take out something over here in order to get to a difference of squares. So we're first going to take out a common factor. So if we take out 2, we are going to end up with 4y squared. That is a square. And over here, we're going to end up with 16. That's also a square. So now we can apply our difference of square rules, which is going to give us 2y plus 4 and 2y minus 4. Okay. Do you guys have any questions up to here? So our third method, that we can use in order to get back to the sides that we need for our factorization, get back to the brackets, is if our first term is 1. What do I mean with this? The common form of the quadratic equation looks like this: ax squared plus bx plus c. If there is nothing in front of our x squared, then it means that our a is 1, and then we can use this method over here. Okay, so what happens here is we are going to need factors of c that are going to give us b in some way. So let me do a few examples. So h squared plus 11h plus 24. So we are going to look for factors of 24. So let's go write them down. We've got 1 times 24. We have 2 times 12. We have 3 times 8. We have 4 times 6. That's all of our factors. So we need to find some of these that are going to give us this 11. So over here, this is a plus, which means that our signs in our brackets are either going to be a plus and a plus or a minus and a minus. In order to figure out which of these it is, we're going to look at this one. This is a plus. So we know in our brackets, we're going to have a plus and a plus. And since this is a plus, we know we have to add our factors. We can already go write h plus and h plus in each of our brackets. So now we also know we need to go add in order to get to 11. So 1 plus 24 gives us 25. That's not it. 2 plus 12 gives us 14. That's not it. 3 and 8 gives us 11. Those are our factors we're going to use. So you can literally go write them in like that. So let's go test it using FOIL. So we have our firsts, that is h squared. We have our outsides, that gives us 8h. We have insides, that gives us 3h. And we have our lasts, which gives us 3 times 8 is 24. So if we go sort this out, we get to h squared plus 11h plus 24. So we're good. Okay, so this was the example. If this is a plus and this is a plus. So second example, we have z squared minus 13h, 13z plus 36. So this is a plus, which means we're going to have either a plus plus or a minus minus. So we go look at this one over here, that gives us, that's a minus. So we can go right in our brackets, z, z, and minus, minus. Okay. So far we're good. Because this is a plus, we know we need to add. So a plus tells us we need to add. So we need to go add all the factors of 36. So we have 1 times 36. That gives us 37 when we add it, so it's not going to work. 2 and 18. That gives us 20. That's not going to work. 3 and 12. That gives us 15. That's not 13. That doesn't work. 4 and 9. 4 plus 9 gives us 13. Those are the factors we're going to use. So we can go write them in. And now we go test it using FOIL. So first is z squared, outsides, that gives us minus 9z, insides minus 4z, and our lasts gives us a minus times a minus is a plus. 4 times 9 gives us 36. So we get back to exactly this expression that we had in the first place. Okay, so that was if this is a plus. What happens if this is a minus? So we've got x squared minus x minus 30. This is a minus. So that tells us that we are going to have a plus minus in our brackets over here. Okay, and now we can look at this one. This tells us our biggest factor is going to be a minus. Okay, and because this is a minus, we are going to subtract our factors in order to get to this. So we can go right in already, x, and a plus and a minus, and we know our biggest factor is going to have the minus. So let's go get our factors of 30. We have 1 and 30, and if we subtract these, we get 29. That's not going to help us. So 2 and 15, subtract them, we're going to get 13. 3 and 10, that's going to give 7. And then 5 and 6. 5 and 6, if we subtract them, gives us 1. So this is the ones that we're going to use. This is a minus, so we know our biggest factor goes with the minus. So that's our 6, and this is our 5. Okay, so now we can go and use FOIL to make sure that this works. We've got our firsts, x squared, our outsides, that is minus 6x plus 5x minus 30. That works out. We're correct. Great. The best thing about quadratic factorization is you can always check whether you are correct. So our last example, we have y squared plus 2y minus 35. Okay, so this minus tells us that we are going to have a plus and a minus, and we are going to subtract. We look at this sign, we know our biggest factor is going to have the plus with it. So we can go right, y plus minus, and we know our biggest factor is going to go over here with a plus. So our factors of 35, we have 1 and 35. That's gonna give us 34. That's not gonna work. And then we have 5 and 7. That is going to give us our numbers that we need. So our 7 goes over here because it's our biggest factor, and our 5 goes over here. Okay. So lastly, we have the case if A is not 1. Okay. So this means our ax squared plus bx plus c, this number is now a number. It's no longer, there's nothing in front of the x squared. So the first thing we have to do is we have to check if there is a common factor that we can take out. Because if there is, maybe we can just use method 3 instead of method 4. So if we can't take out a common factor, then we are going to do the following. So here's our question. We have 3x squared plus 8x plus 4. Okay, I'm going to do 2 methods. Our first method is the split B method. Okay, so this is the one they use in your books. You are going to look at the factors of A and C, so 3 and 4, that are going to give you B. So first, let's multiply them together. So 3 times 4 gives us 12. So our factors of 12 is 1 and 12, 2 and 6, 3 and 4. Okay, this is a plus. So we know in our brackets, we're going to have either a plus and a plus or a minus and a minus. So we look at this one. This is a plus, so we know we're going to have a plus and a plus. And since that is a plus, we know we need to add our factors. So 3 and 4 gives us 7, 2 and 6 gives us 8. So that's the ones that we're going to be using. So now we are going to take out, let's get rid of this. Okay, we are going to take out our common factors from this equation. So we have 3x squared. We're now splitting this b into 2 and 6. So we have 6x, and we have 2x, and there is our 4. So we took this 8, and we turned it into 6 and 2. So now we can go take out common factors from here and from here. So we're going to end up with 3x times x plus 2. And we're going to end up with 2 taken out here with x plus 2. Now we can take out this x plus 2 as a common factor. So we have x plus 2, and we have 3x plus 2. There's our 3x, there's our 2. So this is our answer for that. The second method is the both factors method. This is the one that I am most familiar with and the one that I prefer. You guys can use any method you want. If it makes sense to you, use it. It's better to have one method that you know very, very well than to try and have 10 bajillion methods. Okay, so the both factors method, I'm going to have the factors of A, and I'm going to have the factors of C. So the factors of A, it's very easy. There's 1 and 3. That's easy. Factors of C, we can have 1 and 4, or we can have 2 and 2. So now we can multiply in these ways. We can either do this, multiply this value with this value, this value with this value to get us to our B, or we can cross multiply, meaning we multiply across. So this is a plus. We know we're going to have to add. So 1 times 1 gives us 1. 3 times 4 gives us 12. 12 plus 1 gives us 13. That's not going to work. Okay. So now we can try this one. 1 times 2, or it can be 1 times 2. We can cross multiply or multiply straight across. So 1 times 2, that gives us 2. And 3 times 2 gives us 6. 2 and 6, that works. Okay. So the only bit about this method is we need to be careful where we put our numbers. We know this is going to be a plus and a plus. There's going to be some x's, and there's going to be some numbers. I left a little space in front of these x's for a reason. Okay, so the way we multiplied, if we multiplied this way across, then that means that this is going to be our first and our last. So here we're going to have 1, and we're going to multiply it with 2. We're going to have a 3, and we're going to multiply it with 2. See why I mean that you have to be a little careful with where you put your numbers. Lastly, go double check it with FOIL. If you use the both factors method, always check with FOIL. Okay. So we have 1 times 3. That gives us 3x squared. Here we have 2 times 3. That gives us 6x plus 2x plus 4. Yeah, okay, we're good. That makes sense. So I'm going to do one more example of this method. So here we go. We have 6x squared minus 7x minus 10. So first, let's do the split B method. Okay, 6 times 10 gives us 60. So we need factors of 60. We have 60 and 1. We have 30 and 2. We have 20 and 3. 15 and 4. And 12 and 5. This is a minus, so we know we need to subtract in order to get to this 7 over here. So 12 minus 5 gives us 7. So those are the ones that we're going to use. So now we're going to write out our B differently. We've got 6x squared. We're going to do minus 12x plus 5x. These added together needs to give us that minus 7. So minus 12 plus 5 gives us minus 7. That's how you know where your signs are supposed to go. And then we have minus 10 over here. So now we take out the common factors. So we have 6x over here. That's going to give us x minus 2. And here we've got 5 that we can take out. So here we have x minus 2. Then we take out common factor again. So we have 6x plus 5. And we have x minus 2. Okay, so that's the split B method. So now for the both factors method. So I'm going to write it again. Okay, so factors of A and factors of C. So factors of A, we have 6 and 1, and we have 3 and 2. Factors of C, we've got 10 and 1, and we have 5 and 2. Okay, now this is the bit that takes a bit of time. We're going to have to multiply across and in sections in order to see which ones will work. So we'll start with 6 and 1 and 10 and 1. 6 times 10 gives us 60. Minus 1, that's not going to work. Okay, 6 times 1 gives us 6. And the 10, that's going to give us a 4. That's not going to work. Okay. So now we need to move on. This one and this one did not work. So now we need to try this one and this one. Okay. So 6 times 5, that gives us 30. Minus 1 times 2, that's going to give us 28. That's not going to work. Okay. Now we cross multiply. So we have 6 times 2. That's going to give us 12. Minus 5. That's going to give us 7. Okay. So we're going to use this one, and we are cross multiplying. So now we can go write our brackets. That's a minus, so we know it's going to be a plus and a minus. There's going to be an x and an x. So now we just need to